Welcome back, student. Let us start the new module of this chapter, Wave Theory of Light. Now in this module we are going to discuss about the Polaroid. So what is Polaroids and how this Polaroid will be acting as a polarizer and analyzer. So let us see what is this Polaroid. So we can say, hey, what is Polaroid? So Polaroids are nothing but the large sheet of synthetic material. So consider this is a large sheet of synthetic material. In that case, so it is packed with tiny crystals of a dichroic substance. So as we have discussed in earlier module, that dichroic crystals are nothing but the crystals that will show this unequal absorptions. Okay, so we can say in this case, so this is nothing but this tiny crystals of this red crystals, benzene crystals are nothing but the tiny crystals of dichroic substance. Okay, now oriented parallel to each other. So in this case, we can say the crystallographic axis of all that crystals are parallel to each other. Okay, so all axis, or you can say all axes of all that crystals are parallel to each other. Okay, so that it transmits wave having only one specific direction of the electric vector. So we can say it will transmit a light which is vibrating or which will vibrate only in a single plane. Okay, so we can say when this unpolarized light, that is a light in which vibrations of electrical field is possible in all possible plane, is passed through this Polaroid, then what will happen? Then we can say after this, the light whose vibrations of electrical field is parallel to this axis of this Polaroid will get passed, and all other light whose vibrations are in different plane will not pass through this Polaroid. Okay, so we can say, and these Polaroids are nothing but, so we can say in MCQ there may be questions. So Polaroids are nothing but basically it is a ultra microscopic crystals of quinine iodosulfate. So generally it is made up of quinine iodosulfate. Okay, and we can say this quinine iodosulfate is also called herephthite. So that can be the MCQ question. Then that what is the another name for this quinine iodosulfate? So we can say this quinine iodosulfate is also called herephthite. Now we can say how this Polaroid will be acting as a polarizer and analyzer. Okay, so we can consider this. So in case of Polaroid, there is a characteristics plane which is called transmission plane. Now when this light is incident on polarized, then what will happen? Then the vibrations parallel to transmission plane will pass. So we can say when light will incident on Polaroid, then the light whose vibrations are parallel to the transmission plane of Polaroid will get passed, and all light whose vibrations are in different plane will not pass through that Polaroid. Okay, so we can say all other vibrations eliminated, and finally whatever light we will get, that will be plane polarized, or we can say that light, in that case the vibrations of electrical field will be confined or restricted in a single plane. Okay, so we can say, let us consider this as an unpolarized light. When this unpolarized light or non-polarized light will pass to this Polaroid, then we will be getting this transmission plane. So this red plane is indicating transmission plane. So this is a transmission plane in which there is a vibrations of plane polarized light, or we can say in this case there is a vibrations of electrical field which is confined in a vertical plane only, and all other planes, all other vibrations of lights are restricted, so it will be eliminated. So finally it is doing the process of polarization. Okay, now so we can say when two Polaroids are kept parallel to each other and light is incident on it. So let us see what will happen when these two Polaroids are parallel. So we can say when this light, that is unpolarized light, is incident on Polaroid, then we can say only the light whose vibrations are parallel to the axis of Polaroid will get passed. Okay, so we will get only the light whose vibrations are parallel to this axis of Polaroid. So we can say only the light whose vibrations are in vertical plane will pass through that crystal, that is with Polaroid, and we are getting plane polarized light. Now again that plane polarized light is passed through second Polaroid. Again we can say the vibrations of that plane polarized light and that axis of Polaroids are parallel to each other. So again we can say that light will get continue, and that light will continue, and finally we will get light, that is something but plane polarized light whose vibrations are there in a vertical plane. So from this we can conclude that when crystallographic axes of these Polaroids are parallel to each other, then light will continue, light wave continues. Okay, now what will happen when we change the position of second Polaroid? So we can say if Polaroids are in cross position, or we can say if this Polaroid is rotated, in that case this intensity of light will goes on decreasing, and when this second Polaroid is exactly perpendicular to this first Polaroid, or we can say when the second Polaroid is in cross position with first, in that case there is no light, or intensity of light becomes zero. Okay, so we can say then there is no light, so there is no light which is emerging from that second Polaroid. So finally from this we can say this Polaroid is acting as a polarizer also and analyzer also. Means this Polaroid is nothing but doing the job of polarization. So it is restricting the light to vibrate in a single plane, and it is analyzing also that whatever light we are getting, that is either plane polarized or not. So we can say in this cross position, after the second Polaroid we are not getting any light. So from this we can say this Polaroid is analyzing that whatever light we got before this is plane polarized. Then only we are not getting any light after this Polaroid. Okay, so that's it for this module. Thank you.